Hello guys, welcome back. So this is the video where we discuss the GATE previous year questions on network theory, and here we have a question from GATE EE this time, and this is from 2023 paper. So the value of parameters of the circuit shown in the figure are R1 equal to 2 ohm, R2 equal to 2 ohm, R3 equal to 3 ohm. So this is the circuit, and the inductor and capacitor values are also given. And for time t less than 0, the circuit is at steady state with the switch K in closed position. So here is the switch K. So this is closed, meaning that R3 is coming as part of this entire network. If the switch is opened at t equal to 0, so t equal to 0, we are disconnecting this R3. The value of the voltage across the inductor VL at t equal to 0 plus in volts is dash, and round it off to 1 decimal place. So this is again our basic similar problem of LC circuit, where we use the two concepts, right? Which is nothing but for inductor, your IL of 0 minus is equal to IL of 0 plus, and for capacitor, VC of 0 minus is equal to VC of 0 plus. So here let us try to find IL and VC at t equal to 0 minus. So at t equal to 0 minus, this is actually closed. And let us actually replace the values. R3 is 3 ohm, R1 is 2 ohm, R2 is again 2 ohm. Do we actually need the values of L and C? We don't require, right? Unless we have something to find like dV by dt, dVL by dt, and dic by dt. We don't actually need the L and C values. Okay, so let me copy this. Okay, so now if you see, for long time, if it is in steady state, our L and C will actually be, so our C will be open circuited and our L will be short circuited. So this equivalently I can write it as 10 ampere, and in parallel with this 3 ohm, and here there is 2 ohm, right? So this together is equivalent to 2 into 3 by 2 plus 3, which is equal to 6 by 5 ohms. So what is the voltage across this? It is 6 by 5 into 10, which is nothing but 12 volt. So this is 12 volt. So what will be the current in each arm? This will be 4 ampere and this will be 6 ampere. So can you trace it back here? So here this is 4 ampere and this is 6 ampere, right? And what will be my VC? VC is nothing but the voltage across this 2 ohm, which is nothing but 12 volt. So this plus minus 12 volt. So did we get our IL of 0 minus from here? It is nothing but 6 amperes, and my VC of 0 minus is 12 volt. So now let us take the other case for t equal to 0 plus. So t equal to 0 plus, what happens? This is open circuited. So this part we can ignore. So we only have this part, right? So we only have this part of the circuit, and we have the initial condition. So the current flowing in this arm should be 6 ampere, and already 10 ampere is coming here. So what will be the current in this arm? It will be, let me take a different color. So this will be 4 ampere, right? Okay, and we already know this is 12 volt, right, from the previous thing. We need to find what is VL. So how do we proceed? So first let us find this total voltage. So this is nothing but, let me call it V. So V is nothing but 2 ohm into 4 ampere, this voltage plus VC, which is 12 volt, which is nothing but 8 plus 12, 20 volt, right? And that V is also equal to 2 into 6 ampere, 2 ohm into 6 ampere plus VL. So 20 is equal to 12 plus VL. So VL is equal to 8 volt. So this is my answer. So this is very easy to arrive at. And you want to round it off to 1 decimal places. So it is 8.0 and it is in volts. Okay.